Okay, so now, so this is project 2. So you already done, so if you remember, the idea about the projects was that you wanted to get some, practical, applications and practice with those to see how we can use the material in this class. The first project, we did it right at the beginning. We didn't, there weren't many lectures. It was the first 1 week or 2 of the course. So I gave you those, very simple, practical applications of probability in real life decision making, which, didn't need any background. Hopefully you found it useful. Now the second project, now you have learned all of these, beautiful material. So we can get some coding, and so what we're going to do, we're going to implement a spam filter like the ones that you use, your email, that spam, filtering emails. And the idea is that we use the, Bayes rule. And this is actually a practical algorithm. Most spam filters use, Bayesian framework. Usually in practice, you can combine a few algorithms to make it more powerful. But no matter what, the Bayesian approach has proven to be very helpful and practical and powerful in spam filtering. So there was a question, a homework question. We don't need to solve it right now, but just letting you know that we have already kind of started looking at this. If you remember, there was a question in chapter 1. I don't remember, maybe it was homework 2, that based on some information that you wanted to compute the probability of an email being spam, right? Probability of spam, given that some word, in this case, refinance, was in the email, right? And you computed that probability and, using Bayes, right? We already done this, and, we don't need to go over it again. So the idea was that, so the basic premise here is that spam emails are usually different than normal emails because of the word content, right? And if you have enough examples of spam emails, we can kind of learn what kind of word usually used in spam emails, and kind of based on that, detect if an email is a spam or not. Okay, so that's kind of the idea. So and of course, now we have learned random variables, so we're going to use random variables in this context. So a very simple Bernoulli type random variable, x is equal to 1 if, for example, in this case, the word refinance belongs to the email and 0 otherwise, right? And then you have another Bernoulli random variable y, which essentially says, is the email spam or not? So you want to observe x and, observe x and then predict y. Very simple, right? Suppose that we start with one word, very, very simple spam filter. We just look at one word and we want to use x to predict y. So how do we do this? Well, you're going to say, we need some training data, right? We want to learn. So suppose that this is your training data, right? So the idea is that, the idea of machine learning is that you have a bunch of training data. From that training data, you obtain your prediction machines and then use it to predict future data, right? And at any point, if there are any questions, please let me know. Okay. So X here shows that if the word refinance belongs to the email or any other word, and Y is it spam or not? So from our this is our training data. So we already know the correct answer. In this case, the word, X was X is 0. So the word wasn't in the emails, and Y was 0. It wasn't a spam. Again, X was 0, but in this case, it was a spam. So you see, there is a probabilistic. We cannot completely predict Y from X, but there is a probabilistic notion. So how do we do this? Well, based on this training data, we obtain this probability of a spam given our observation. And if that probability of a spam is larger than probability of not spam, we're going to say it's a spam. And because there are only 2 possibilities, essentially we need to compare it with probability 50%, right? Does it make sense? So the main idea is the following. So we look at the observation, the random variable x, 0 or 1. If the probability of a spam given x is larger than not spam, we say spam. If the probability is smaller, right, we say not spam, right? You can easily see my mouse here. Good. Okay, so let's do it. Very simple. So I want to compute the probability that is spam y equals 1 given x equals 0. How do I do that? You already know how to do it. Essentially, it's the probability of A given B, which is probability of A and B divided by probability of B. Or even simpler than that, you look at all the cases that x is 0 and count how many of them have y equals 1, 2. In other words, this is the notation that I'm using throughout the document. So make sure you, so this says the number of pairs or data points where x is 0 and y is 1 and divided by the number of pairs that x is equal to 0. Does it make sense? Right? So I have done it here. And you see that, the ones that I shown, this, all of them, for all of these values, x is 0, right? So how many of them are there? 5. How many of them y is equal to 1? Only 1. So the probability of y equals 1 given x equals 0 is 1/5. That's it. You're done. Right? Now, of course, if I ask you probability that y equals 0 given x equals 0, we already know that probability of not A is equal to 1 minus probability of A. And it doesn't matter if you have condition on something. So the same idea, this condition is there, but probability y is 0 is 1 minus that, 4/5. Or you can actually look at the training data. You see 4 of them are zeros and then 4/5. So 1/5, 4/5. So I have done the probabilities. So now I have my prediction machine, right? What do? I need to look at probability that y equals 1 and compare it to probability y equals 0. So my prediction machine is very simple. In this case, if x is 0, probability is 1/5, probability of spam. If x is probability y is equal to, so if x is equal to 0, the probability of spam is 1/5. Essentially is less than 4/5 probability of not spam. So the conclusion here is that if x is 0, I just predict not spam. If x 1, I predict spam, right? We can do it. I mean, I will show it later, below. But is that clear for everybody? If x 0, the probability of spam is 1/5. Right? So being spam is less likely than not spam. So I just say not spam. Questions so far? Good. So let's repeat the same thing for x equals 1. The same thing, the same idea. I'm going to see how many cases that I have x equals 1, right? Probability of spam given x equals 1. There are 3 of them, and only 1 of them is spam. No, sorry, 2 of them are spams. Y equals 1. So the probability is 2/3. So in this case, probability of spam given x equals 1 is 2/3, and probability of not being spam is 1/3. In other words, this is kind of a spammy word, right? If you look at the table, most of the time that x appeared, y was 1. And most of the time that x was 0, y was also 0. So if x is present, it makes sense. We say it's a spam email, and if it's not, then it's not spam. So the conclusion, our prediction says if x equals 1, predict spam. So far, so good? Okay. So now, so far we have done just training, right? This is not enough. What do I need to do now? When I'm training my machine learning algorithm, what is the next thing that I need to do? Test it. Yeah. We need to test it with some new data, some unseen. So we need to look at the test data. So let's do it. So I have my prediction machine. Let's test it. So this is my test data. And then I implement my prediction machine, which is very simple. It essentially says that if x is 0, predict 0. If x 0, predict 0. If x 1, predict 1. Right? So I implement my prediction machine, and then I compare it with the actual data. Is you see, so the first row I predict correctly. The second row I predict incorrectly. Third row I predict correctly. Fourth correct. Fifth correct. And then here I make a mistake. Y is 1, but by hat, y hat is my prediction. 0, and again 0, 1, again error, and then correct. So test accuracy, that's what matters, right? At the end of the day, you want to have good test accuracy for new data which was not used in the training phase. You want to see how good your algorithm works. Essentially, it's as if you're testing it on new emails, right? You want to see how good your algorithm works. In this case, I correctly predict 5 out of 8. So my accuracy is, 62.5% or 5 out of 8. Any questions so far? Okay, so it's not that good. Well, you want to have definitely better than this. What do we do? So by the way, we're done. So this spam filter is done, but I guess you can get the idea what we need to do to improve this accuracy. We don't want 62%. We want, I don't know, 95%. What do we do?
Need more data.
So more data, but what do you mean?
Train it. More conditions.
More condition, which is more
Different words.
words. Yeah. So we don't need to look at one word. We need to look at a lot of words, right? So all you need, we do from now on is extension of this simple idea, right? To looking more words. So let's do it. And that's going to be the, your project. So to make our prediction more accurate or more powerful, we look at more words. So I presented for 2 words, X1 and X2, but you can easily extend the idea to M, which M could be 1,000 words, right? So let's say instead of looking only on one word, I look at a vector, X1 and X2, 2 words, right? X1 could be 0 or 1. Again, everything is binary here, right? From that, I want to predict spam. So this is word 1. This is word 2. And I'm going to predict if Y is spam or not, right? So let's do the same thing for using more words, okay? So if there are any questions at any moment, please let me know. So I want to compute probability that Y equals 1 given whatever I observe. X1 was present or X2 was present, I and J, are either 0 or 1, right? So given my data, I want to predict probability that Y equals 1. And again, the same thing. If Y is more likely to be spam, probability of Y equals 1 larger than probability of Y equals 0 given the data, then I predict this. So that's kind of the idea. So as I said, we need to compare probability that Y equals 1 given the observation, compare it to, is it larger than probability that Y equals 0 given the observation or data, okay? So now we use Bayes rule again. You are experts in applying Bayes rule. So I am looking at probability, let's call this B1, let's call this B2. Probability of B given A is, as we all know, hopefully, is probability of A given B times probability of B divided by probability of A, right? So we need to compare these 2 things. But as soon as I look at this comparison here, one good thing happens. Can somebody tell me what is the good thing that happens here? Look at this equation. I need to compare these 2. How can I simplify it?
Divide by PA.
Exactly. I can just ignore P of A because in both sides is a positive number. So I don't care. So all I need to do is compare the numerator. And then I'm going to be in business. So that's what we're going to do. We need to compute 2 probabilities, probability of A given B, probability of B, and then compare them, and we are in business. So if you understand what you're doing, this project is easy, very easy. You can implement it, finish it, in less than 2 hours. So, excuse me. Okay, so let's do it. So let's start with the easier component, which is probability of B1. What is B1? Probability that Y equals 1. And what is B2? Probability that Y equals 0, right? First of all, probability that Y equals 0 is 1 minus probability of Y equals 1. So we only need one of them. Now, how do I compute probability Y equals 1? Very simple, using my training data, right? Probability that a certain email is a spam. I look at all my training data, count how many of them are spam, the percentage, and that's probability of Y equals 1. That's it. Very easy to estimate. So probability that Y equals 1 is the total number of data points where Y equals 1 is spam divided by the total number of labeled emails that I have, right? Let's say I give you 1,000 emails. From those, 300 of them are spam. So probability that Y equals 1 is estimated to be 0.3 or 30%. And usually we put some hat here because it's an estimation, right? When I put an hat, I mean, I am estimating probability of y equals 1. Probability of y equals 1 could be different because, I don't see all the emails in the universe, right? I just see my training data. Okay, so far so good? Okay, so we want to implement that. You see that for the second term, probability of y equals 1, we don't need anything new. The first term might be a little bit scary. It's a probability, it's a big probability. And that's where we use naive Bayes algorithm, which I'm going to explain next. Okay. So the idea behind naive Bayes is assume conditional independence, right? You know what independence means? Independence means probability of A and B is equal to probability of A times probability of B, right? Conditional independence is the same thing. It's just saying that probability of A and B given C, these A and B are different from those B1 above, right? Is equal to probability of A given C, and you have seen it in lectures, probability of B given C, right? I'll just add condition to everything. This is the idea about conditional independence. Condition on y equals 1, these two events are independent. So the idea behind naive Bayes, so the naive Bayes algorithm simplifies this probability by assuming conditional independence. What it means is that in this case, I can write this probability of x1 equals I is again, I and j are 0, 1. Probability of x1 equals 0, 1, probability x2 equals 1, 0, 1. Given y equals 1, I just multiply each probability, right? And so this is very, very brilliant and very powerful. So for two reasons, this step is extremely good. The first reason is simplicity, right? Make it easier to estimate because you already know what to do, right? You can easily estimate each probability, right? This is like above. Remember, it's just one variable. We already did it for the refinance problem at the beginning. We had only one word, and I can easily compute these probabilities. So all of these probabilities I can estimate as before, and we are done. So computationally, it's good. But there is another reason, and I want to know if anybody can point that out. So what am I doing here? And maybe specifically those of you, I don't know how many of you, but those of you who read the last chapter of the book, right? The artificial intelligence or machine learning. So here I am kind of restricting my model, right? I have a general model. I restrict some condition on it, right? That conditional independence. I make my model restricted. So why is it good? It helps me to avoid what? Everybody understands the question? So the question is, this is naive Bayes. Naive Bayes says, okay, you want to do this probability, assume conditional independence, right? And simplify it this way. So assume conditional independence. So my question for you is, this is good for two reasons. The first reason was computational, which I mentioned. But the second reason is interesting. If I have a machine learning model and I restrict a model, why is it helpful? Yes? Exactly. It helps with the overfitting problem. If I have a very complex model that has a lot of flexibility, it always fits to the noise, right? Rather than to the data. So this has two advantages, computational and two, avoiding overfitting. Again, just for your own knowledge. But so at the end of the day, for project 2, what you need to do to implement this simple rule, and then you have your prediction machine. So because you can easily, as I said, estimate these probabilities as before. When you want to estimate this probability, what you need to do is, this probability here, you just count how many x1 is equal to I, whatever I is 0 or 1, and then count it with the total number of ways or the data points where y equals 1. Exactly the same formula as above. So you see, you should be able to do this. You get your training data. Instead of one x, you have a bunch of x's, but you can still compute the probabilities, estimate them using this way, and you're done. There is one little minor point left. There is a problem with this. What if there is 0, right? For example, I don't have any spam email that contain the word chocolate, right? Let's say one of the words are chocolate. It doesn't mean that the probability of spam being chocolate is 0, right? It's just, it means that it was rare. I didn't observe it in my data. So to avoid 0 probabilities, we do some sort of a smoothing thing, right? And very simple. We just add some constant k to the numerator and to the denominator. K over 2k. Now, why is it k and 2k? K is 1, 2, 3, 4. The reason it's binary, right? Let's say if k goes to infinity, what happens? The probability becomes 1 over 2, 50%. So when you put k infinity, essentially you are ignoring your data. You're just saying that the probability that x 0 or 1 is equal to 50%. But we don't want to do that. We don't want to ignore our training data. We just want to avoid 0 probability. So we just add some little thing to the numerator and denominator to avoid having 0 probabilities. Okay, so that's a kind of a numerical thing. People discover these things when you implement these algorithms, and this is a nice trick. Avoid 0 probabilities. It essentially helps with the overfitting issue. So we just use this smoothing parameter. This k is smoothing parameter, and in instruction your project, I gave you, everybody uses k equals 1 so that we all get the same result. Okay, so this, if you go to Moodle, this is the instruction for project 2. So what you need to do, so I put the matrix. I just need to give you the matrix, right? You download it. It's in MATLAB, but you can use any language that you like. MATLAB, R, Python, C, Java, whatever language that you like. Everything is acceptable. Yeah, assembly, everything. Yeah, whatever you like. Okay, so you need to submit your project is in a single PDF file that includes everything, right? So, and you need to document and explain your code properly, and give me your test accuracy, right? So here's what you're gonna do. So the training data that you're gonna, when you load the data, it's gonna look like this. It's gonna give you one X and one Y. Okay. So X is the matrix that has n rows, m columns, and this is the first word, second word, and the last word, right? And this is the first training point, right? So it was the first email. This is email 1. Each row kind of shows one email. So email 1 did not have the first word, did not have the second word, whatever that is, and the third word was present, right? And the email was not spam. Okay. So I have a nicer picture here. Okay. So this is the matrix X that you download. This is word 1. In this case, this is email 1. And each row shows another email, right? Email 2, and so on. So in email 1, word 1, X1 was 0, was not present. Word 2 was not present, and the third word was present, and so on. And if you look at your training data, each row I, essentially is email I, right? And these are the training, the data, and it tells you it was a spam. This one, the next one was not a spam because Y is 0. So that's your training data. Download it, you have your training data. You can use the formulas that I explained above to make your prediction machine. Okay. So here are your steps. You need to implement all of these steps to achieve happiness, or at least happiness in terms of this project. So let's kind of don't aim too high. Okay, so here's what you're gonna do. You need to estimate, you're using your training data, these probabilities that we mentioned, right? Probability that X equals 1 given Y equals 0. And we know how to do it, right? The formula that I just explained above. Count how many of the emails that Y equals 0 have X equals 1, and you had that K to K to kind of a smoothing factor, and you will be done, right? And everybody uses K equals 1. And then you need to estimate, the reverse probability is simple, right? If you know probability that X equals 1, probability that X equals 0 is just 1 minus that. So you don't need to do it twice. You just compute probability of X equals 1, and then from that, you compute probability that X equals 0. And finally, you need to estimate probability that y equals 1 and y equals 0, which is again, it's just counting how many ones divided by the total number of emails, and you will be done. And of course, when you do that, you have everything that you need. So you implement your prediction and evaluate using the test set, right? So I'm giving you, if you look at the instruction, sorry, in Moodle, you have training data XY and test data X2, Y2. So these are separate. You train using your training data, you use test using your test data. Okay. Now, since I am a nice professor, I have already done this myself. I'm just showing you my code just to tell you how I implement it, which is kind of you see that there is very short. I didn't try to be even efficient, but you see how it works. So I just loaded the data, so which is given in the instruction, and then I choose the smoothing factor k equals 1. Then I trained, and then I evaluated. Right, these 3 steps: load the data, train, evaluate. Okay. When I train, what do I need to know? I need to know probability that y equals 1, right? And also need those probabilities above, right? This probability that, xi equals 1, given y, is equal to 0 and y is equal to 1, right? And then I need to evaluation. So the way I implement it using a simple function, right? Train function. And you see in my code, I don't want to go into all of it, but it's nothing complicated here. So let me just zoom a little bit.
Let's sleep tonight, I guess, in future nights.
Why? Okay.
I have to type this out.
It's gonna, yeah, don't try to decipher my code. It's easier for you just if you understand what I explained. It's a very nice experiment because it tells you how this stuff that you are seeing in this course is really used in practice. You are using it every day when you open up your email thing. So yeah, this is just, for example, probability. I count how many ones divided by n, then probability. This is just formula. You see, I add k divided by 2k. I count how many of those there. So, very simple thing. I just implement above, and then I am checking which probability is bigger. Is probability that y equals 1 bigger, right? Which is y probability that y equals 1 bigger or y is 0. And I compute this using the naive Bayes rule, the conditional independence. You see, I have estimated all of these terms above. Right, that's what I did above, and I just do this multiplication, and see which one is bigger, right? I call the first one B, the second one A, and then I have a simple line. If A larger than B, predict 0. If B is larger than A, predicts 1. So I do prediction, and for my test data, I already have the answer. So I compare, and I see how many of them I do correctly. So at the end of the day, the accuracy is just divide the total number of data points, the number of times that I predicted correctly, right? Is, predict correctly divided by the total number. And hopefully that number is, I don't know, 95%, 96% or something. Okay. So that's the entire project that you need to do. And I will post this document on the project page. It's not there yet. I was just finished writing it this morning. But so the key point here, again, look, let me just tell you something. It used to be for this course, we didn't have projects. Instead, we had computational exercises, which were due at the end of, a course or finals. And I feel that this is much better because, first of all, those computing exercises used to be at the end of the semester. Everybody was busy with exams. And also, they didn't give you the idea how practically use this material in this course, because those computational exercises used to be just implement some of the homework questions that you see in, MATLAB using simulation. But I think this is much more useful. You see that you can effectively use the stuff that you learn in this class to solve a real world problem. So I think, even if you don't do this, I mean, let's say you just don't want to do projects. The fact that we talk about it in the class and you see how this can be used in practice, I think it's useful. But I really hope that you just do it. Again, it's not complicated. I'm sure you can all do it. And you will be fine. And hopefully you find it useful and rewarding. Okay, any questions? Yes.
Does everyone get the same exact answer or? Does it
Yeah, because you all have the same training data and yes, some test data, right? So theoretically, you should get the same answer, but some weirdly, I did it last year, another semester. The answers were a little bit different, like very, very small in the percentages. Like, so it might be some numerical issue or something. I don't know, depending on how you implement what language and things like that. But yeah, no, I mean, somebody should not get 75% and another person 99%. That shouldn't happen. But minor differences is okay due to numerical issues. Now, any other questions? Yes. It's due April 15th, tax day. So, same deadline.
Imagine doing it on tax.
Yeah, so no, the reason I put it on tax day because this is
Finance.
definitely much more rewarding than doing your taxes. So hopefully. Any other questions? Is that clear? Any comments? Any issues? So here's what we're gonna do. Again, as I said, to make things efficient, I'm gonna post this recording on Moodle. However, in the next discussion classes, I try to solve problems so that everybody get all of everything. So make sure that, I mean, this you can refer to it when you are doing your project, maybe before getting started, watch it quickly.
5 times speed.
Yeah, 5 times speeds, exactly.
5.
Yeah. Yeah, exactly. So, and then do that. And yeah, I think you find it useful. Any comments, questions, concerns? Yes.
We have to submit a picture of our notes today. There wasn't.
Oh, sure. Yeah, I just make it available. Yeah, you need to submit as always, just make sure you were present. As I said, just simple note.
Don't be a champ.
Yeah.
I forgot to do it last week. And I submitted it like
I submitted mine
16
late.
hours late.
But you were present. Yeah, that's okay. If you were present and you forgot, just let us know. That's
I
okay.
did, and I submitted 0.
You got a 0?
Yeah, I mean, I said a comment, I was like, I completely forgot, but I still submitted my
Well,
notes.
it's because it was put late.
But I did
Oh.
submit it the next day, because I forgot, I like woke up.
Was it already graded when you saw?
Yeah.
Oh, maybe that's just send an email to me and say that I was
How
present.
much of the grade is it?
I don't know. It's given in the syllabus. Yeah, it's given the syllabus. Yeah, and you can miss 2 discussions without any penalties.
Oh, okay.
Oh, I'll save it up.
That's about 1 or 2. right there.
But I'm sure that you are enjoying this discussion so much that you don't want to miss 2 discussions,
Yes.
right?
I hate the stupid attendance stuff.
So I hear we have to attend our lecture.
Okay, any other questions or comments? Let me stop recording because it seems that we are done with this. We don't want to record the entire,
Oh, shoot. He's recording.
yeah, it's still
I'm
recording.
kidding, I'm just joking, I'm just joking.